Okay, what it says is a car speeds up from 85 meters per second to 105 meters per second in 10 seconds. And we want to know how far it drives while it's doing that, while it's speeding up. So let's start, as always, with the information given to us in the problem. What do we have? What do we know?
We know the time,
Yeah, what do we have for a time here?
10 seconds.
Times 10 seconds, great. So delta t is 10 seconds, good. What else do we know?
Would it be the initial?
Would which be the initial?
The 85 miles per second. Is it meters per second or miles?
Meters per second, right? Meters per second. A mile per second. A mile is a really long way to go in 1 second, right?
Sorry, 85 meters per second.
Mm-hmm.
And then the final would be 105 meters per second.
Right. So our initial and our final velocities, right, are 85 and 105 meters per second. So Vxi is 85 for initial velocity. Vxf, 105 is final velocity, right? So we've got 3 givens. That looks good. And then one, what are we looking for? What's it asking? Which symbol? Which quantity?
For the distance?
For the distance, right, Jose, exactly. So we have delta x, right? That's our distance or displacement that we need to find. Okay, so if we have the delta t, the Vxi, the Vxf, and the delta x, which one of these big 4 equations should we use?
The first one?
Yeah, the first one, that's right, because the first one is the only one that has delta t, Vxi, Vxf, and delta x. Right, so we'll pick the first equation. Delta x is 1/2 of the initial velocity plus the final velocity times the time. Okay, so step 4 now is to rearrange the equation, right? Do I need to rearrange the equation today?
We don't need it.
You don't need to, right? We're looking for delta x, and delta x is already by itself on one side, so no algebra is needed. We can just plug right in. So 1/2, my initial velocity, that was 85 meters per second, plus my final velocity, which is 105 meters per second, times my time, which is 10 seconds. So I can do that on the calculator. So I get 0.5 times 85 plus 105, and then times 10, I get 950. And if I have meters per second times a second, seconds cancel out, and I just have meters for my unit. And that's what I expected since I was looking for a displacement. And that's a pretty good speed, so traveling 950 meters in that time seems pretty reasonable. Are there any questions? I should have checked the answers today because this one I think a lot of people would have gotten. But are there any questions on this one? Anybody have any problems with it? No? Okay. Okay, I think that's good then for today. There's another problem a day up for today. But we'll go over that one tomorrow. Thank you guys all for showing up today and for reading, those of you that read. And we'll pick it back up with chapter 13 tomorrow.
Bye, mister.
All right, have a good one.
Bye.
Bye-bye.